and welcome to this tutorial video on solving the Move Zeroes LeetCode problem. In this video, we will explore an efficient approach to rearranging an array by moving all the zeros to the end while maintaining the relative order of the non-zero elements. I'm about to present to you a solution that utilizes a simple and intuitive algorithm. We will be using the power of pointers to efficiently swap the elements within the array, allowing us to achieve the desired result in place without making a copy of the array. Also, we will break down the problem step by step, explaining the logic, syntax, and mechanisms behind each line of code. By the end of this tutorial, you will have a clear understanding of the solution and be able to implement it yourself. And whether you are a beginner starting your coding journey or an experienced programmer looking to enhance your problem solving skills, this video is for you. The Move Zeroes problem is a common interview question, and understanding its solution will not only sharpen your programming abilities, but also prepare you for similar challenges in the future. So without further ado, let's dive into the solution and unravel the intricacies of the Move Zeroes problem. Please join me as we explore the fascinating world of algorithms and data manipulation to solve this coding challenge together. How exciting! Let's get started. Well, as I mentioned earlier, the intuition behind this solution is to use the pointer to keep track of the position where non-zero elements should be placed. By iterating through the array, we can identify non-zero elements and swap them with the element at the current position. Here's a breakdown of the intuition. First, we start by initializing a pointer variable to keep track of the position where non-zero elements will be placed. And second, we iterate through the array using a for loop and the range function. This allows us to examine each element of the array. And third, for each element at index I, we check if it is non-zero by comparing it with 0. If the element is non-zero, we proceed with swapping it. And step 4, if the current element is non-zero, we swap it with the element at the current pointer position, and this effectively moves the non-zero element to the front of the array. And lastly, after swapping, we increment the pointer by 1. This ensures that the next non-zero element will be placed at the correct position during the next iteration. By repeating these steps for each element in the array, we move all the zeros to the end while maintaining the relative order of the non-zero elements. The key insight is that the pointer helps us track the correct position for non-zero elements, avoiding unnecessary swaps and maintaining the order of non-zero elements. And this approach achieves the desired outcome of moving zeros to the end of the array in place without making a copy. The time complexity of this solution is O of n, where n is the length of the input array nums. This is because we iterate through each element of the array once in the for loop, and performing a constant number of operations for each element. the space complexity of this solution is O of 1, as it uses a constant amount of extra space. The space usage remains constant regardless of the size of the input array. The algorithm modifies the input array in place without requiring any additional data structures or dynamic memory allocation. And the code here starts with defining a class named solution. This is a common practice in LeetCode problems to encapsulate the solution logic within a class. And within the solution class, the Move Zeroes method is defined. It takes two arguments, self, which is a reference to the instance of the class, and nums, which is the input integer array. And this method does not return anything. And before the iteration begins, a pointer variable named pointer is initialized to keep track of the position where non-zero elements will be swapped to. This pointer helps maintain the relative order of non-zero elements. The for loop iterates through the array using the range function and the length of the nums array. This loop allows us to examine each element of the array. For each element, nums I in the array, and an if statement, for each element nums I in the array, an if statement is used to check if the element is non-zero. If nums I is non-zero, the code proceeds with swapping the non-zero element. This line, nums pointer nums I equals to nums I, nums pointer, swaps the non-zero element nums I with the element at the current position of the pointer, which is nums pointer. This effectively moves the non-zero element to the front of the array, and after swapping, the pointer is incremented by 1. This ensures that the next non-zero element will be placed at the correct position during the next iteration. The loop continues until all elements in nums have been processed. And finally, the modified nums list is returned by the method. And once again, the Move Zeroes function is void, meaning it does not return any value. It simply modifies the original nums array in place. I hope these key insights and concepts will help you grasp the core logic and mechanism of the solution. The approach is based on iterating through the array, identifying non-zero elements, and swapping them to the front while maintaining their relative order. This process effectively moves all zeros to the end of the array. Alright, that's all for today. Remember, practice is crucial for mastering LeetCode problems. Please try solving more similar problems and gain familiarity with different techniques. And if you have any questions, please leave a comment. I hope this was helpful, of course. But if you have any questions, please leave a comment. And also, please subscribe to my channel, like the video, and click the bell icon to receive the latest updates. Happy coding, and thanks for watching. Goodbye.